Assalamualaikum dan salam sejahtera. Okay, for the final lecture for today, today is going to be your last lecture on the topic of momentum and collision. Okay, we're going to look at collision in two dimension. Okay, I recap apa yang saya dah ajar anda sebelum ini dalam topik collision. Okay, you have looked at inelastic collision. Okay, dan apakah ciri-ciri inelastic collision atau pelanggaran tak kenyal. Okay, kita dah tengok juga pelanggaran kenyal atau elastic collision. Okay, what are the characteristics? How you're going to form the equation using the conservation of momentum and kinetic energy. And today, we are going to go into collision in two dimension. Bezanya lecture hari ini dengan lecture semalam adalah semalam kita hanya tengok pelanggaran kenyal dan tak kenyal dalam satu dimensi. Either in the X direction atau Y direction atau Z direction. But today we are going to use the same concept using the conservation of linear momentum and conservation of kinetic energy. But kita akan tengok collision yang melibatkan dua paksi, iaitu either XY, YZ atau XZ. Okay. So today kita akan tengok bezanya pelanggaran di antara satu dimensi dengan dua dimensi dia tak banyak, konsep dia masih sama. Tetapi bila anda mempertimbangkan pelanggaran dalam dua dimensi, dia melibatkan dua paksi. Right? So the first statement says that the vector nature of momentum, especially in two dimension, is very important. Okay, so that's part dia yang dua dimensi ni hanya melibatkan vektor sahaja. Okay, peleraian dan gabungan vektor. Okay, the common type of non-head-on collision is that a moving object strikes a second object initially at rest. Okay, so now we look at kalau dia initially at rest, maknanya second body itu atau yang dihentam itu tidak bergerak pegun ya. So using the same law, okay, kita masih mempertimbangkan law of conservation of momentum for inelastic collision dan law of conservation of linear momentum and kinetic energy for elastic collision. So for this, in this case, the law of conservation of momentum states that, okay, when you look at the equation, dia ada bahagian X dan bahagian Y. Anda kena pecahkan dia kepada komponen yang berasingan. Using the same law, but you break it off into two different components. Okay, we look at the X component saja. Okay, you have the total momentum before as P1x plus P2x. Okay, then the total momentum after is P1fx plus P2fx. Okay, kita hanya mempertimbangkan conservation of linear momentum pada paksi X sahaja. Okay, so because the second mass, okay, yang dihentam itu adalah static atau pegun, so you only have the first body punya momentum, that is P1x. Okay, kita tulis sebagai M1v1. Okay, then after that is equals to M1v1f cos theta and M2v2f cos psi. Okay, kita akan tengok kenapa dia jadi theta dan psi dalam gambar ajar selepas ini. So, okay, so when you look at the second part, using the same law of conservation of momentum, but for component Y, kita ada P1y plus P2y equals to P1fy plus P2fy. Okay, when you look at the equation, bahagian sebelum itu, dia semua jadi kosong. Sebabnya, pelanggaran itu berlaku pada paksi X. Dia tiada komponen Y sebelum pelanggaran. Jadi, kedua-dua momentum sebelum pelanggaran pada komponen Y adalah kosong. Okay, then the second part, kita dapat M1v1f sin theta minus M2v2f sin psi. Okay, this is how the image looks like. Okay, when you look at the blue ball, okay, in the slide, when you look at the blue ball, it is the first mass. Okay, it is moving. Dia ada velocity of v1i, but the second mass, that is M2, dia pegun. Jadi dia tak ada velocity. Okay, when it hits, okay, the blue ball goes up and the yellow ball, the orange ball tu goes down. Right, so that's why dia bergerak, yang blue ball tu bergerak atas daripada paksi X dengan sudut theta. Dan the orange ball bergerak ke bawah paksi X dengan sudut psi. That's why when awak leraikan momentum selepas pelanggaran untuk the blue ball, you have M1 V1F cos theta untuk paksi X dan M1 V1F sin theta untuk paksi komponen X, komponen Y untuk the blue ball. Okay, same goes for the orange ball. Okay, anda leraikan M2 V2F itu kepada komponen X dan Y. That's why you have M2 V2I cos psi ke komponen X dan negatif M2 V2F sin psi untuk komponen Y. Dia ada negatif sebab psi itu pada paksi Y itu dia heading down towards the negative Y axis. Okay. So, if the collision, kalau inelastic, kita hanya mempertimbangkan conservation of linear momentum. Sebabnya tenaga kinetik sebelum dan selepas pelanggaran tidak sama. Jadi kita tak boleh guna the conservation of kinetic energy untuk inelastic collision. Tetapi untuk elastic collision, kita boleh guna dua-dua conservation law. Okay, so dia kata if the collision are elastic, maknanya kita boleh guna conservation of energy atau kinetic energy atau momentum. Okay, so another form of equation that comes from the conservation of kinetic energy is half m1 v1i squared equals to half m1 v1f squared plus half m2 v2f squared. Right, this is the common equation. Okay, when you're considering two dimension, you can break it off into the x and y component. Right, so when you look at the equation that I formed in the slide before, from equation 1, 2 and 3, so you can solve for any of the parameters. Okay, kalau apa yang ditanya dalam soalan, okay, dia tanya hal laju sebelum, hal laju selepas, you can solve by using the two laws of conservation, okay, kinetic energy and momentum for elastic collision dan conservation of linear momentum untuk inelastic. Okay, so in two dimension, the equation becomes slightly complicated because anda dah pecah kepada x dan y component. It has a lot more parameter termasuk angle. Right? So when you use, when you are solving for any of the parameters, okay, dalam topik collision ini, anda hanya mempertimbangkan the law of conservation. Okay, in your form 5, maybe you have studied about the restitution punya constant. Pemalar restitusi yang E tu kan, E sama dengan kosong, E sama dengan 1. Okay, at this level, I'm not going to teach you that because that is just memorizing, right? But in this, at this level, you are going to study momentum and collision by using the conservation law. Okay, jadi apa-apa soalan yang saya beri dalam tutorial atau final hanya berdasarkan the conservation law. Okay, do not use any of the restitution punya constant atau pemalar dia, coefficient, restitution coefficient. Right, do not use E sama dengan kosong tu. Sebab at this level, you are supposed to derive the formula, the equation from the conservation law to solve any of the questions yang ditanya. Right? So, we are going to see 3 examples after this. Okay, the first one says that a billiard ball atau snooker ball lah, okay, moving with its speed v1 equals to 3 meter per second in the positive x direction, strikes an equal mass ball. Okay, the keyword is equal mass. Dia mempunyai mass yang sama. Initially at rest. So the second ball is at rest. Okay, you know that when the second ball is at rest, okay, the V2 tu tak ada, kosong. The two balls are observed to move off at 45 degrees, ball 1 above the x-axis and ball 2 below the x-axis. Okay, so you have the line of motion pada x-axis tu. Selepas pelanggaran, satu bola tu bergerak 45 darjah di atas paksi x dan satu lagi bola bergerak 45 darjah di bawah paksi x. Okay, so kita tandakan theta sama dengan 45 dan psi sama dengan negative 45. Negative 45 ni moving downwards lah. So the question said that what are the speeds of the two balls? Alright, so when you look at the image, it looks like this. Before the collision, M1 is moving with a velocity of V1I. M2 is static. Okay, yang gelap tu tengah-tengah tu. After the collision, M2 move upwards, okay, pada theta 45 darjah, okay, dia ke atas paksi X, dan M1 dia bergerak ke bawah dengan theta sebab dia 45 darjah dua-dua. That's why saya use theta dua-dua. Okay, pada kelajuan V1F. Right, so this is the image for the two balls after the collision and the balls before the collision. Right, so when you're trying to solve, okay, when you look at the image just now, you can see that the two balls are moving at a symmetry way. Maknanya atas 45, bawah 45 tu disebabkan dia mempunyai mass yang sama. Okay, we assume that the two balls have the same speed. Right? So using the conservation of momentum, linear momentum, kita pecahkan dia kepada komponen X dan Y. So you have the first equation for the X component as mv1 equals to mv1f cos 45 plus mv2f cos negative 45 because it's moving dia ke bawah Jadi kita tengok dia punya v because m tu sama untuk mass dia semua sama. Okay, equal mass kan. Jadi kita can cut off the m from the equation. You have v1 equals to v1f cos 45 plus v2f cos 45. Sebab cos 45 and negative cos 45 is the same Jadi dia disebabkan kita ambil dia assume to have the same speed. So you have equals to 2v1f cos 45. Okay, pada komponen y pula, when you look at before the collision, okay, semuanya bergerak pada paksi x. Jadi dia tak ada komponen y. So that's why pada y tu, komponen y tu, before the collision, okay, the total momentum is 0. Right? So it's equal to mv1f sin 45 plus mv2f sin negative 45. Okay, from these two equation, okay, yang x dan y ni, anda simplifykan dia untuk dapat the final speed of the two balls. Okay, so you have v1f and v2f, right? So v2f is equal to negative v1f sin 45 over sin negative 45. Okay, so sin 45 over sin negative 45, you get negative 1. So that's why v2f is equals to v1f. So you need to find one velocity sahaja. Okay, satu velocity tu akan mewakili dua-dua bola sebab kelajuannya sama. Okay, so v1f equals to v2f sama dengan v1 over 2 cos 45. Okay, so you have, when you insert the data from the question into the equation, you have the answer as 2.1 meter per second. So the ball 1 is moving 45 degrees above the x-axis, okay, at a velocity of 2.5 meter per second, and ball 2 is moving at the direction negative 45, okay, that is below 45 degrees below the x direction, positive x direction, at 2.1 meter per second. Both of the balls have the same velocities. Okay, we look at another example. Two objects slide over a frictionless horizontal surface. Maknanya bila keluar perkataan frictionless, kita harus ignore rintangan, okay, atau friction, right? So tak kira dah friction apa, kinetic friction ke static friction, kita kena ignore, right? So the first object, okay, mass m1 ni is equals to 5 kg, is propelled with speed of v1i equals to 4.5 meter per second towards the second object yang mempunyai mass 2.5 kg. Okay, yang saya highlight hijau tu Jadi awak kena tengok, awak kena hati-hati. Okay, when you look at the mass of m1 and m2, their m1 is double the mass of m2. Okay, which is initially at rest. After the collision, both objects have velocities which are directed 30 degrees on either side of the original line of motion of the first object. Okay, soalan dia adalah, what are the final speeds of the two objects, and is the collision elastic or inelastic? Okay. Okay, when you know that dia bagi sudut maknanya dia adalah satu pelanggaran dua dimensi. Okay, then in your head it should be automatically kita kena pecahkan dia kepada x and y component. So when you adopt the coordinate system, okay, jadi kita nak tahu, in this case kita gunakan conservation of momentum along the x-axis. kita akan dapat M1 V1I equals to M1 V1F cos theta. And M2 V2F cos theta juga. Okay, jadi dia 30 degrees kan atas dan bawah. Okay, dan dia tak ada M2 V2I kerana objek yang dihentam, that is M2, tidak mempunyai kelajuan. Alright, so that's why M2 V2I ni adalah kosong. Okay, you form the first equation. Okay, then conservation of momentum along the y-axis akan memberi anda kosong sama dengan negatif M1 V1F sin theta plus M2 V2F sin theta. Because one of them is moving downwards. Jadi ke arah negative y direction, that's why one of the parameter ada negatif. Okay, sebelum pelanggaran tu, semuanya adalah kosong kerana pelanggaran sebelum total momentum before the collision, okay, dia hanya bergerak pada x-axis saja, dia tak ada y-axis. So that's why it is 0. So when you look at the second equation, you have 0 equals to negative M1 V1F sin theta plus M2 V2F sin theta. You pindahkan M1 V1F sin theta ke sebelah kanan persamaan. You have M1 V1F sin theta equals to M2 V2F sin theta. Okay, kita nak simplify. So from equation 1 and 2 that you formed just now, when you combine, it will give you the final velocity of the two balls, that is V1F, okay, and V2F. V1F is equals to 2.5981 meter per second, and V2F will give you the value of 5.91962 meter per second. Okay, when you look at the velocity of the two balls, okay, remember what I've said just now. In the question, it states that the mass of M1, the first ball, is double the mass of the second ball. So you expect after the collision, the first ball will move slower, okay, than the second ball, because the mass is directly double antara dua tu. When you look at the answer for the velocity, it is also double. So the first velocity of the first mass is 2.5, and the second mass mempunyai velocity of 5.2, is nearly double of the first mass. Okay, selalunya macam tu. Okay, so you look at, kita tanya the second question, the initial kinetic energy of the system. Okay, kita sekarang we are trying to prove whether the collision is elastic or not. Okay, so daripada ciri-ciri pelanggaran elastik, okay, ciri dia adalah the total momentum before and after is the same, dan juga the total kinetic energy of the system before and after must be the same. That is elastic collision. Tetapi untuk inelastic, dia tidak macam tu. Okay, untuk inelastic, the total momentum before the collision is the same as after, but the kinetic energy of the system is not the same before and after for inelastic collision. Okay, now we are trying to prove whether or not the the collision is elastic or not by proving, okay, value of the kinetic energy before dan after is the same. Okay, kita cari the initial kinetic energy of the system tu sebelum. Jadi kita dapat half M1 V1I squared. Okay, sepatutnya dia ada half M2 V2I squared kan, tapi sebabnya ball kedua itu adalah pegun, kita abaikan. Okay, jadi dia sifar. Okay, when you insert all the data into the equation, you have it at 50.63 joule. Okay, then the final kinetic energy of the system, tengok the kinetic energy datang daripada dua mass itu. Kita dah dapatkan V1F dengan V2F dia tadi. So you insert all the data from the question and what you've calculated in the part A, okay, akan dapat juga 50.63. So it's proven, okay, initial kinetic energy dan final kinetic energy dia sama nilai dia. Jadi kita boleh nyatakan atau kita boleh kategorikan pelanggaran dalam example ini adalah elastik atau pelanggaran kenyal. Okay, the third example. Okay, it says that a 20 kilogram body is moving in the direction of positive x-axis with a speed of 200 meter per second. When, owing to an internal explosion, it breaks into three parts. One part, whose mass is 10 kilogram, moves away from the point of explosion with a speed of 100 meter per second along the positive y-axis. And the second fragment, with a mass of 4 kg, moves along the negative x-axis with a speed of 500 meter per second. Kemudian dia tanya, sebab dia break off into 3, okay, jadi dia tanya what is the speed of the third fragment and how much energy was released in the explosion. Ignore gravity. Okay, ceritanya adalah dalam question ini, you have a 20 kg body, dia bergerak elok aja dalam positive x-axis, tak pasal dia meletup dan pecah kepada 3 fragment. Okay, one goes up, okay, dia naik pada positive x-axis, dia 10 kilo tu. Okay, second fragment tu dengan mass of 4 kilo, dia terbalik, dia balik-balik ke belakang, negative x-axis. Okay, because the body is moving forward, positive y-axis. So, satu fragment tu terbalik pergi ke belakang, negative x-axis, dengan speed of 500 meter per second. Then dia tanya, apakah kelajuan the third fragment? Of course, 20 minus the first part, 10, you have left with 10. Then you minus the second part, you minus 4, you have left with 6. Okay, kemudian dia tanya how much energy was released. Okay, when you look at the image, gambar tu, yang M besar tu adalah induk dia. Dia tengah bergerak dengan kelajuan V, elok je pada positive x-axis tu, kemudian dia pecah kepada 3. Satu M1 tu mempunyai mass of 10 kg, it goes positive Y, dan M2 dengan fragment M2 tu dengan berat 4 kg, dia bergerak ke belakang dengan kelajuan V2. Then we have the third one. The third one kita tak tahu pergi mana, tapi kita tanda je lah pada image tu, pada sudut theta dengan kelajuan V3. We are trying to find what is the speed. We know that the mass dia adalah 20 tolak 10 tolak 4, dia adalah 6 kg. Okay. Since the force of the explosion is an internal force, the total momentum of the system will be conserved. Okay, bila explosion tu, force itu adalah suatu daya luar, kita tidak boleh menggunakan conservation of linear momentum kerana total momentum is not conserved kalau dia adalah satu external force. Tapi disebabkan force explosion, letupan itu datang daripada dalam sistem itu sendiri, maka total momentum of the system adalah terabadi. Okay, so in this case also kita pecahkan dia kepada x dan y component because dia dah satu naik ke atas kan, positive y, dan satu pergi ke belakang, negative x, dia dah ada dua paksi, melibatkan dua paksi. Jadi kita kena gunakan secara vektor untuk selesai, dia dua dimensi. Jadi conservation of linear momentum along the x-axis, kita have the mother, induk dia tu, m besar, v besar, sama dengan mv minus m3 v3 cos theta minus v2 m2. Ini ada paksi y, paksi x, dan m3 v3 cos theta tu, kita pindahkan m2 sebelah ni, kita akan dapat the first equation. Okay, then kita tengok pada y-axis pula. Okay, mother dia tak adalah, induk dia tak ada pada y direction sebab dia bergerak pada positive x-axis. You have m1 v1 that is moving upwards minus m3 v3 sin theta. Kita pecahkan m3 tu kepada x component dan y component. Okay, simplifykan dia. Move m3 v3 to the right side of the equation. You have m3 v3 sin theta equals to m1 v1. Then you have the second equation, right? So squaring both equation 1 and 2, kuasa 2 kan, sebab kita nak hilangkan cos theta sin theta tu. Okay, dari kuasa 2 kan. Okay, you have m3 v3 cos theta squared sama dengan mv squared plus m2 v2 squared. Okay, when you combine the upper equation and the first equation and the second, you have m3 v3 squared sama dengan mv plus m2 v2 squared plus m1 v1. Okay, sin dengan cos dia hilang. Okay, dari mana ke mana hilangnya? Sebabnya kita pakai sin squared theta plus cos squared theta is equal to 1. We are trying to get that. We are trying to eliminate the cos theta and sin theta. Okay, you have the third equation. So solving the equation, masukkan data dalam soalan itu ke dalam persamaan yang ketiga itu, you will have the velocity of the third fragment that is 1014 meter per second. Okay, third fragment tu yang 6 kilo tu. Okay, jadi dia mempunyai kelajuan 1014 meter per saat. Okay, so that is the end of the 3 example. Okay, I've covered with you collision, elastic collision, inelastic collision. You have looked, kita dah tengok sama ada the first case, okay, di mana kita deal dengan satu dimensi, and the second case, the second lecture ni, second part of the lecture is on the 2 dimension. Okay, jadi menggunakan daripada awal lecture saya recap semula menggunakan momentum. Kita dah tengok apa dia momentum, apa dia impulse. Okay, impulse macam mana kita combinekan momentum ini menggunakan conservation of linear momentum, and we applied it to collision. Kita dah tengok elastic collision, inelastic, okay, dalam satu dimensi dan dua dimensi. Okay, so I end my 4-hour lecture here. Okay, dan esoknya hari Rabu anda akan jumpa dengan Dr. Zainal untuk topik circular motion. Okay, so kita finish topik momentum and collision. Anda akan jumpa saya sekali lagi selepas Dr. Zainal habis, tetapi on a different topic, that is on gravitation. So, thank you dan Assalamualaikum.